Hello everyone and welcome back. My name is Mr. Kowalt, and in this video I'm going to be going over how to calculate the amount of oxygen that's absorbed in your lungs when you breathe. So let's get into this. So the partial pressure of oxygen in the air is 158 millimeters mercury at 25 degrees Celsius, and the total pressure is 760 millimeters of mercury. The air that is expired from your lungs after breathing has a partial pressure of oxygen of 115 millimeters of mercury under the same conditions. How many moles of oxygen are absorbed by your lungs from the 1.0 liters of air? Okay, so we're breathing in air. That air that we breathe in has a certain amount of oxygen. We're told that it has a partial pressure of 158 millimeters mercury. But then when you breathe it out, it has a partial pressure of 1.15 millimeters mercury. That's the oxygen we're talking about. So you lost oxygen. So let's go ahead and write down this information and then figure out how to solve it. Okay. So we're given partial pressure of oxygen and air is 1.5. So before, okay, so I should say when you inhale, when inhaling, partial pressure of oxygen is equal to 158 millimeters of mercury. When exhaling, the partial pressure of oxygen is 115 millimeters of mercury. So we can figure out the amount of oxygen that was absorbed by your lungs by subtracting out the before and after. So before it was 158, after is 115. So the difference is what was absorbed by is due to what was absorbed by your lungs. So let's figure out that pressure amount. So 158 minus 115 gives us 43 millimeters. Oops. Sorry about that. Knocked over a chair. Okay, so this is going to be 43 millimeters of mercury. And so the 43 millimeters of mercury is due to, that's the missing amount, right? So we lost 43 millimeters of mercury of pressure. That's because that was due to the amount of oxygen that was absorbed by the lungs. So we're going to use this difference to then find the moles. But we need to use the ideal gas law. So let's list the other information we're given. We're given a temperature of 25 degrees Celsius. So temperature is 25 degrees Celsius. We're going to add 273.15 to that because we need to convert to Kelvin. And so that's going to give us 298.15 Kelvin. Next, what else? We're given a volume of 1.0 liters of air. So the volume is equal to 1.0 liters. So we got temperature, we got volume, we've got the pressure. Let's write that down. So the pressure due to the oxygen absorbed is going to be equal to 43 millimeters of mercury, but we need to convert this to atmospheres because our R value, the ideal gas law constant, is going to be in units of atmosphere. So let's go ahead and convert that. So then I know that 1 atmosphere is equal to 760 millimeters of mercury. So I'm going to put 760 millimeters of mercury on the bottom. That'll cancel out. And then I end up with 1 atmosphere on top. So then when I divide these two, I get 0.05657, 0.05657.9 atmospheres. Okay, so I have Kelvin temperature, I have the volume in liters, I have atmosphere. So now I just plug this into the ideal gas law. So PV equals nRT. So we want to find, what are they asking for? Moles. So we want to find moles. So it's going to be N is equal to PV over RT. So we're going to plug in the pressure. So pressure is 0.05657.9 atmospheres. The volume is 1.0 liters. So 1.0 liters. Okay. R is going to be 0.08206 liter atmospheres over Kelvin mole, multiplied by the temperature, which is 298.15. So 298.15 Kelvin. And so now all we need to do is multiply and divide. But notice that atmospheres cancel out, liters cancel out, Kelvin cancel out, and I'm left with moles, which is what I want. I want moles. So then when I calculate this out, the number of moles is equal to 0.0023. And so notice sig figs here. So when I added these together, the last significant digit in my temperature is the 8. Because remember, when you add and subtract, your answer should have the same number of decimal places as the least number. I have 0 decimal places, so I stopped there. But I kept a couple of digits to avoid rounding error. Here they gave us 1.0, that's 2 significant figures. And here we have 2 significant figures from the pressure. So that means that the least number, when we multiply and divide here, the least number, our answer should have the least number of sig figs, and the least number is going to be 2 here. And of course, the pressure, we have 2 there because we have 2 here. So remember, we're only allowed the same number of digits. So this is exact. This is an exact relationship, so we ignore that. So we have 2 sig figs here. So that means we should have 2 here. So then we have 2 here. We have 2 there. So the least number is going to be 2. So the answer is 0.023 moles of oxygen were absorbed into the lungs or by the lungs for breathing in 1.0 liters of air. I hope this is helpful. If you enjoyed this video, if this helped you in any way, then please, by all means, like the video, share the video, hit that like button down here somewhere. Also, do me a favor, subscribe to my channel, hit that notification bell. When you do, make sure you click all so you'll be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or problem you need answering, or if you have a topic you want me to cover, write that down below. I would love to do that for you. Thanks for joining me and have a great day.